Hello everyone and welcome to the Streamline tutorial series part 3. Today we are going to be going over how proximity targeting works in Streamline and how to get that set up for your systems. So in Streamline, having your Niagara systems follow the spline like this is pretty nice, but what if you want what is on the spline to follow something else? That is what proximity targeting is for. As we can see on the ribbon example here, we have the flame ribbon on this spline following the orbiting ball here. And this takes advantage of the proximity targeting properties that you can add to your Streamline systems. So to get started, let's go and hop into a new level to create an open world here. And now that we're in it, let's go ahead and add the Streamline blueprint. And this is a pretty small spline, so I'm going to draw out a new spline. This is going to be a pretty linear spline, so you can really see how the targeting works along it. Okay, we've got our spline drawn in. Let's go over to our blueprint here and sample it. Okay, it's all sampled. We can get rid of our spline actor and just focus on the Streamline blueprint. Okay, so you can build this system yourself just fine, but for the sake of brevity today, we're just going to use the pre-built ribbon system. We are going to go and create a new Niagara system, and we will take advantage of the Streamline templates that we have here. We will use the ribbon example. We'll create this. We will call this proximity target test. And we can put the proximity target test onto our Streamline system here, and as you can see, it is now working. We have the ribbon along the full course of the spline and our little flame right here in the middle. Just in the middle by default, this has nothing to do with proximity targeting as of now. Okay, so to set up proximity targeting with this blueprint, we need to first go to our data sends. In this case, I already know that this Niagara system here uses the proximity target position, so I will enable this. Nothing's happened yet. We need to go down here and make sure use proximity targeting is on. We'll see the flame has now disappeared. And we are going to start with using smooth proximity targeting. Normally, proximity targeting will use the subdivisions. You give this line up here, and it will only go to whichever one of these points is closest to the target. However, when you check smooth proximity targeting, it uses the entire spline. So we will see that the flame has appeared at the far end of our spline, and this is because our proximity target position here we can see on the screen is right at the end. If you're wondering what this little extra bulb is here, this is just Unreal Engine's 5.4 visualization of the vector fields that you can have in blueprints. Okay, so now proximity targeting will be working on our spline. So I have the proximity target position selected here. We can see it's right alongside the spline. So if I go and drag this along, reselect it there. If we go and drag this along, you'll see that the flame follows this little position along the spline. If I drag it out here, the flame doesn't follow it out to here. It still stays on the spline, but still the closest point to this position. So I can move it on down the spline and it will follow it wherever it finds closest. It's basically performing a spherical collision intersection from this point, and then whichever point on the spline hits that sphere first, that is the proximity target position for the spline. We can move it along all the way down, and it's just following the line very simply right now. Now, if we want to see what this looks like subdivided, we can turn off smooth proximity targeting. We'll see it just teleported back to the end of the spline right now. So right now, we only have one spline subdivision. If you don't know what this does, you can go check out part 2 of the Streamline tutorial series to go check out how spline subdivision works. This will be linked in the description. But for now, we will proceed, assuming you know how this works. So, once we have just one subdivision, it will have either the beginning here, or we can snap it and it will snap to the end. And this is based off of the closest points, basically rounded, so it either rounds to start or the end. And so if I go, in the middle here, it's going to round there. And then if I go on this side, it's going to round over here. If you're wondering why it's kind of chosen roughly right here as its halfway point, that is because this operates off of spline keys and not the spline percentage of the entire spline. The spline key is basically from each one of these points to the next. So this spline encompasses 4 total points, and this point right here is the halfway point of those 4 points. And so each of these spline keys would be 0, 1, 2, 3, and 4 because they start index 0. But what this means is that it will unevenly find its target position on the spline if these points aren't evenly spaced out. So this far end right here is much longer than this side. However, in the key notation, they are still considered the same length. This can become a bit more obvious if we scale up the subdivision 2. We will see how it behaves a little differently. So right here, this is key 2. This is considered the halfway point of this. So this is key 1 right here. This is the new halfway point between this point and this point. So whenever I pass over key 1, it's going to jump to this end. And of course, this is going to be the midway key between this key and this key. So it's going to jump to the end there. And then you can scale this up and have as many points that you want to jump to as possible. Just keep in mind it will be scaled with where all of these keys are. Now we can start looking a bit further into the Niagara system that runs this. First of all, I want to point out when you go to data sends, there are 2 different versions of the data you can send for the proximity target. You can either send it as a Niagara position or you can send it as a vector. Some are easier to work with than others depending on the circumstance that you're using this data in. For this system, we're using positions because it gets plugged right into a position input. However, that really, it will depend on whatever you want for how you want to use these. Okay, let's get into the system itself. All right, so we jumped into the proximity target test system. This is just the template of the Streamline ribbon system here. We have 3 emitters. So we have the ribbon along the spline. This is the whole line of the spline right here. And we have the sparks and the flame ribbon. So those are the parts of the system that follow the proximity target point on the spline. So when we look at these systems, we can see what's really going on here. So we have the shape location spline module that will project all of the spawn particles right somewhere on the spline, depending on what's in there. We have the same with the sparks here. And with ribbon along spline, we are using a ribbon as spline node. This is specialized specifically for arranging particles into a ribbon on a spline. You can go explore around with this more. We won't have a tutorial directly on it. It's pretty simple. It just projects things directly onto a spline as a ribbon. What we're really focused on is the shape location splines right here and these 2 emitters and what they are doing to the particles to make them follow that proximity target point. So when we go into the sparks system here, we can go down to the distribution and we see we are using the direct distribution. So this is finding only one point along the spline, and it is putting all of the spawn particles to that point. And so this only uses the spline U setting in the middle. There is no minimum and maximum for this. So when you open this up, you see that it's in the world coordinate space. That's the coordinate space we're using. And for the position input, we are using the proximity target position user input. What this is, if we go over here to our user exposed parameters, we have a position type parameter called proximity target position. And this is the position sent by this right here. If we wanted a vector user parameter, we would just type in proximity target point, and then we would receive vector data through here instead. So what's happening here is we send this position to this dynamic input called spline-u near. What this does is this finds the nearest point on the spline to the position it's given. Obviously, with its given coordinate space, we want this world as the world coordinate space since we're using the proximity target position in a world coordinate space setting. Now when we drop down a sampled spline, as per usual, we don't need to sample a specific spline since when this is parented by the Streamline system, it will automatically assign this spline right here. However, what is different from a lot of other cases is we are using the lookup table. If we look up here, we can see we don't need to use the lookup table for this shape location spline. We don't need to use it for the ribbon as spline. We don't need to use it in most cases. However, for proximity targeting, it's really important to make sure you use this lookup table. The number of steps is totally up to you. Think of the number of steps being similar to our subdivision sampling for the spline. But really, what this does is this ensures that it gets accurate projection onto this spline when it is finding the nearest point for this position input here. What happens is if we don't do this right now, we still have it in our subdivision mode. So let's turn this off. Let's get it back to smooth. Okay. So right now we can see it just smoothly follows along, and it's right by our proximity target position here. However, if we turn off the lookup table, I will do this with the flame here so it's more obvious. The searching for the proximity target position to the nearest U point, the system does something kind of weird with it, and it doesn't get the exact correct position. As you can see, the flame is now offset here. So these are the sparks. These are using the original nearest spline-u dynamic input, and these are still in the same place. And these have the lookup table enabled. The flame has the lookup table disabled. So something internally with Niagara is a bit weird here, and it really wants the lookup table to get this to be accurate. When you don't use it, the proximity target point along the spline is usually offset by some amount and seems to also be influenced by the key separation of this current region and how close to a key the point is. So that is why it's really important to make sure you turn on the lookup table for all of the proximity targeting that you do to ensure that it finds the true closest point. So this is spline-u near, it's a dynamic input. If we look here, we can go spline, and so that's going to be suggested here if you are looking for a float input, is the spline-u near. We go to dynamic inputs, scroll down, that is the only input that is actually available from Streamline for any float systems in this circumstance. Most of these Streamline dynamic inputs are going to be things more like vector fields here. So this can be plugged in for anywhere that takes any U coordinate, this specific module. This is pretty much how you would proximity target in most circumstances, is you would put in your spline-u dynamic input, you would put in your proximity target position from your user variable here, make sure you turn on a lookup table and have however many steps you find appropriate. There are a few other things you could do for proximity targeting, but this will be what you will be doing most often. Now, this is really cool, you know, having a position to target from right here. If you're not in Unreal Engine 5.4, you won't have this position specifically to drag around. You would just do it here, and it would still work. This is one thing that is really nice about 5.4, is it does let you drag around these little positions. But what if you want to target it to something else? What if you want to target it to an actor? You can go down here to the proximity target actor, and you can actually just select an actor to have it follow. So if we go up to Streamline and we go into the example level, we have this Streamline proximity target actor, and this was made specifically to be an actor to show off proximity targeting on a spline here. It's the black orb you saw revolving around the tube in the example level. All this has is just a simple setting for radius, and so I like to set this to something like 200, and it will just orbit in that radius over time. Pretty simple, but this is a good way of testing your proximity targeting because it provides a very simple system for testing proximity targeting over time and making sure it moves along. Anyways, to get this actor hooked up to the Streamline blueprint, just pick the actor, pick that, and as we can see, the flame has now jumped directly to the closest point of this ball. Now, when you move this around, it will not update the Streamline blueprint because it's not part of the Streamline blueprint. There's no requirement for it to also update this blueprint. So if you want this to update in the editor just for something like this, what you will want to do is you can just do something like click this twice real quick, and then it will retarget to the new point and update the Streamline blueprint while you're in the editor. You can, of course, also just play the level, and if we go over here, you will see the black ball is orbiting and the flame is following as close as it can to that actor. We can close out of this, and that really wraps up proximity targeting and all you need to know about how it works. You can obviously make some really advanced stuff with this, or you can keep it pretty simple. It can be anything from just particles following along a pathway to much more complex stuff I'm sure you can come up with for any of your visual effects or video games that you need. But anyways, that is the end of the Streamline proximity target tutorial. This really wraps up the fundamentals of Streamline. There will still be more tutorials that you can find, and those tutorials will be going over just creating certain systems using Streamline in a more practical sense instead of these more abstract concepts. Those will be tutorials 4, 5, 6, and 7. You can find those linked in the description or just on the Galacticc Games YouTube channel. With that being said, if you found this video helpful or informative, make sure you leave a like so that you can help other people find it. And also don't forget to subscribe to the YouTube channel and ring the bell to make sure that you can get all the information and updates from Galacticc Games. And also go check out our Discord community to get those updates as well and to engage with people using products such as Streamline. Thank you for watching, and I hope you have fun creating with Streamline.